what is temperature? We all get our temperatures taken, right, when we go to the doctor or when we're cooking food, but what is it actually doing? So to toggle off of our previous lesson about heat, heat is energy that causes particles to move. The more heat you add, the faster the particles move. Humans created measurement systems to try to get an idea of how fast the particles are moving. And we did that long before we even knew that temperature or heat caused particles to move, and temperature was actually measuring the movement of the particles. So there are 3 different systems that have been created and widely used, and we're going to look at some of the pros and cons of those. So the first widely used system to measure temperature was the Fahrenheit system, degrees Fahrenheit. We still use that in the United States. Most of the rest of the world has gone away with it. There's some reasons why. It's created by this dude, Daniel Fahrenheit, in 1708. So over 300 years ago, he decided to make 0 degrees Fahrenheit, the coldest day in Danzig, Germany that year. Literally why 0 degrees Fahrenheit is 0. Then 32 degrees was the temperature that water, melts and freezes, happens at the same point. And 212 degrees is the temperature that water boils. It was a great first try. He was the first person to put together some sort of system. But as you can see, 0 being the coldest day in Danzig, Germany in 1708, with a 32 and a 212 are kind of hard to understand. So along comes a guy named Anders Celsius. And 1744, a couple decades later, creates the Celsius system during the scientific revolution and things that were happening around the world when people were creating the metric system. So the metric system being based off of water, Anders decided to make a system where 0 degrees was the temperature that water melted and froze, that 100 degrees is the temperature that water boils or condenses. And that way it would flow nicely with all of the other measurement things in the metric system that are based on water. Great second try. A lot more reasonable, and most of the world uses it because it just makes a little bit more sense. Although to us in the United States, thinking that the temperature inside of our buildings are like 32 degrees Celsius is a little strange. Just like they think it's weird that it's 104 in Arizona. So along comes Lord Kelvin in 1848, a full century later. And by this time, physicists had realized that temperature is the measurement of the movement of the particles, right? That heat makes particles move. So he said, listen, 0 should be the temperature that particles do not move at all, because particles can't negatively move. You're either moving or you're not moving. Then he left the increments the same as the Celsius system. So 273 Kelvin then is the temperature that water melts or freezes. And 373 Kelvin is the temperature that water boils or condenses. That's even stranger to us to be like, oh, it's, 300 Kelvin in the classroom today. That sounds pretty crazy. But he took these negatives away because you can't negatively move. This system is used by physicists. It hasn't really gained a lot of traction worldwide, but when we understand what heat and temperature are, it actually makes a lot of sense. 0 Kelvin then is defined as absolute 0, the temperature that no movement happens. So it makes a whole lot of sense. So then now we're going to look at a thermometer and how these things work, right? So inside of a thermometer is liquid, and when you add heat to the liquid, it expands. And when you remove heat from that liquid, it contracts. As it expands and contracts, it moves up and down the thermometer, right? And so if we add heat, the particles inside of that liquid start speeding up and spreading out and rising up the only space that they have to move, which is the little tube inside of the thermometer. On the side, we gradient out the little measurements. If we remove heat, the particles slow down and clump together, they contract, and the liquid moves down the thermometer tube. And so we can have markings that say 0 degrees Celsius or 32 degrees Fahrenheit or 73 Kelvin. And we can also have readings that say, different temperatures all the way up. And so it doesn't matter what scale, what measurement system is on the side. They all work the same way through this concept of expansion and contraction And then we just made up these systems to define and describe these measurements for ourselves.